Okay, so let's talk about blob. So that's big, that gelatinous thing that sits in movie theaters? That's the blob that we're talking about? No, we're talking about binary large objects, okay? So we're going to talk about where the blob tool can be used, part of the Vision solution, as well as we're going to create and configure one. We're going to be able to find a certain blob in a designated gray level range, and we're going to set up some criteria that filters them. So blob analysis. What we're trying to do is we're trying to look at a two-dimensional representation of some type of image. It's either going to be light on dark or dark on light. And some of the information it's going to give back to you is stuff like area, your center of mass, your perimeter, as well as what your principal axes are. So when would you use blob? Well, blob is great when you're trying to look for something like defects, when you don't know what they're going to look like ahead of time, and you're just looking like something on a light on dark background or dark on light background. Also, when things vary in size and shape. So this is one of the situations you can't train it. You can't use PatMax, you can't use search mats because you have no idea what it's going to look like. Or if you have a distinct shade that you're trying to bring out, something that's not in the background or the foreground, you just want to bring out that shape itself. But keep in mind your objects cannot be touching each other. If they're touching each other, they are all part of the same blob. Think about blob behind the scenes of doing basically a binarizing function. You have what is blob and what is not. That's how simple it is. So what are some sample applications? Well, let's say that you're looking for the number, size, and shape of epoxy dots. Or you could be looking at ink dots on the bad wafer dies. You're just making sure that they're there or not. Let's say you're looking at pharmaceutical pills and you want to see if any of them are broken. So it's a way of saying, hey, do I have a small area because I have two separate halves in there? Or to just sort and classify things depending on their size and shape. So we've got to segment the blob. We have to decide what is the actual blob versus what is the actual background. So there's a couple of different ways that we can do it. Now, one of the things that they're going to ask us for is polarity. Are we looking for light blobs on a dark background or dark blobs on a light background? Comes in very, very important. Then we also have to think about a threshold. Okay, so in this case, if we're doing like a hard threshold or even our soft threshold, we'll talk about the difference between them in a moment, we need to state what is that level at which it decides, okay, this is the blob and this is the background. So we have a fixed threshold. And what a fixed threshold is going to be is you set a threshold and it's going to stay that way no matter what. Okay, so as lighting changes, it's not going to change. It's a hard fixed threshold. So let's say that I'm looking at this part and the actual value of this part is going to be 10 and its background is going to be 90. If I say the threshold is 100 and I'm looking for a black blob on a light background, notice I pick up the whole image. That's because anything that's below 100 is considered blob. So it sucks in both the shape and the background. Now if my background moved up to 160 and the value of my blob stayed at 80 and I say my threshold is 100, then anything under 100 is my blob, anything that's above it is my background, so yes, I do pick up the shape. But now if everything gets brighter, so now my shape is 120 but my threshold is still 100, notice I pick up nothing because there is nothing under 100 grayscale. Okay, it just throws it out. So you can also do relative thresholding, and relative thresholding will adjust as your image adjusts. Okay? So in this case, if I said, hey, I'm looking for 40% of the image, so it's going to do a histogram behind the scenes, find out what 40% of that curve is, and then in this case says, okay, I find my part, but my threshold's only 30 here because it's pretty dark image. And this case where I start getting a little bit lighter, my threshold moves up to 100, but I'm still getting my part. And then in this case, because it's relative, it's adjusting with the brighter light, my threshold moves up to 140 because it's a relative threshold, but I'm still getting the part. So you might say, oh, why wouldn't I use threshold all the time, relative thresholding? That seems perfect. Well, the reason why you would use fixed over relative is fixed is faster. Relative has to take that step of doing a histogram behind the scenes to figure out what that thresholding is. Secondly, and this is where it really comes into play, if you don't find blobs, relative is always trying to find it. So even if you have a black background, you'll never have a completely solid black background. So there is going to be some variation, like between like maybe grayscale of 0 or 1 or something, and it's going to think it finds blobs because it's going to say, okay, 0 is, you know, my blob and 1 is my background, so now you have a ton of blobs sitting there. So it can definitely throw you off. It's always trying to find a blob. Then we have this concept of hard thresholding and soft thresholding. Hard thresholding is, bam, this is the threshold. Okay? Whether it's relative or fixed, we're still saying we are quickly going from what is the part to what is the background. Just have one big delimiting line. So there's a couple of different ways to do hard thresholding. We can do hard relative, where we would state what percentage are we looking for and whether we have a low and high tail. That's just to take out noise. By taking out the tails, you're taking out the bit of noise on it. Or you could just say, hey, I just want a dynamic one. So take out my noise and we'll figure out what it should be from there. Or I can just have a fixed one. I just state a grayscale value, and that's what it is. Okay? So those are your hard thresholds. Now the problem comes in is where your product lines up, or where's your part lines up on your pixel grid, because this is going to change what it counts as being considered blob pixel or background pixel. And this is called spatial quantization error. Now these two blocks are the same size. Okay, the one on the left, if I position it like this on the pixel grid, it looks like it's 64 square pixels. If I move it lightly, just slightly, so now it's touching a few more, I'm now up to 81 square pixels. Did the size of the square change? No. No, but just the amount of pixels that it's touching does. Then you'll notice that you get even a bigger error if you have more perimeter. So here's an H. In this type setting, I have 44 square pixels, but just moving it just slightly drops me down to 25, almost a half. Did it change? No. My size of my image did not change. So you might say, well, how do I get rid of this? Because I could be getting erroneous errors. This is through pixel weighting. And what the pixel weighting is going to do is it says, okay, depending on how you line up on the grid, what that grayscale value is I'm going to decide whether I should count you as a full pixel or a partial pixel or not a pixel at all. So if I wind up directly on 3 of my pixels, I see them as full pixels, 3 full pixels. Now if I move it a little bit, because of the grayscale value, I might pick up 0.4 on this one, 1 in the middle, and then 0.6 on the other. I still end up with 3, but just because of the grayscale value, I'm giving it a different weighting. Okay, and over here the same thing. Because of how the pixel value will end up coming up on this one, I might give this a 0.8. These two are full pixels and down to 0.2. So I'm deciding what that pixel weighting should be. So what we call this is soft thresholding. It's where you still have what is not blob to what is blob, but then you're counting the number of steps in there. So in this case, I'm saying that anything that is grayscale value from 0 to 50 is not a blob. Okay? Anything that's above 65 is a blob. But then we have this range between 50 and 65. That I'm saying that if the grayscale value is between 50 to 55, I'm going to say that its pixel weighting is 0.25. If it's between 55 and 60, I'm going to say it's half a pixel. And if it's between 60 and 65, then I'm going to say it's 3/4 of a pixel. So now it's able to give me some partial pixel, which is going to give me a better representation of what the size of that blob is. So when you do soft thresholding, you have either fixed or relative. So, you know, do you want it to not be dependent on light, or do you want it to change with light? If you don't want it to be dependent on light, you would state what your low threshold is, what your high threshold is, and then how many steps between them. Okay? How much do you want to start dividing that into? If it's relative, then you say what percentage your low is, what percentage your high is, whether you want to take off any tails, and then once again, how many steps between them. So now you're deciding how small of detail do I want to move between there, because it's going to take whatever those grayscale values are between them, split them up into steps, and then say, okay, depending on what your grayscale value, I'm going to give you that much of your blob. Sound good? So that's how we get rid of spatial quantization error.
Is there a limit to the number of softness steps?
They had said 255. What I found it to be is really it's the matter of whole spaces between the grayscale values between what your low and your high step is. Because anything underneath that, how can it? You can't go less than one grayscale value. So I think that's why they said 255, because that's your whole range, but that's even not practical. That's binarized.
That probably severely taxes the calculation time.
Blobs actually work really fast. This is just pure calculation, so yeah, it's not going to throw off your times that much. Not this. This is pure calculation, so the PC does nothing. Both blobs and edges are extremely fast tools.
Is the percentage based on the darkest and brightest pixel in the current image?
It takes that histogram, and it figures out what is 40% of your histogram, what's 60% of your histogram. So that's how it's deciding it. So this one will take longer. Your relative will take longer because it has to do that one step afterwards. But then it adjusts to your lighting level.
This is where setting up an image without saturation is important too.
Well, yeah, but that's just where we're still talking light to dark transitions. So if you kill where your edges are, that's going to throw off your values. So that's just general with any of your tools. Then there's this idea of subtraction image. And this is where you have like a consistent nonlinear type image. And what you want to do is, you know that's always there. You want to remove it so that you can only see what the difference is. I had someone do this with the top cover of an ice cream container. So you know how it has the lip there. And what they were seeing is that it was always shading in. Now, it would always be the same shade. But they wanted to see when they had like some black deviation on there, because it was a white container, so they were trying to see where they had some black spots. So by bringing in the subtraction image, they could subtract out that linear shading that they were always getting from the actual image and just see what's left. And then they could say, oh, what's left is what I care about. Those are the blobs that I want. You can also go in there and do pixel mapping. What pixel mapping allows for you to do is, up to this point, we're either looking for light on dark or dark on light, but this allows for you to dig right into just a specific gray value, gray set of values, or multiple gray sets of values. So let's say that we have dark holes, we have a light background, but we just want to get this gray area. Don't want the dark, don't want the bright, we just want that medium gray. So what I can do is I can go into the pixel mapping, I can go in and say, hey, all of those are actually blob pixels, everything else isn't. So then it will pull out only those values, those grayscale values that fall into that range. That's the blob. Anything else is not. So when I go into pixel mapping, I say map, and I go in there and I choose the grayscale values that I want to choose. So yeah, we could have one range, but you can have multiple ranges. You could have like maybe some light gray and a little dark gray, but you don't want anything in the middle or on the edges. So you can set that up and say, this is all that I want to find. And then it will grab out just that grayscale part of the image. You also have your choice of how you want the connectivity analysis to do. Do you want it to be grayscale, where your grayscale looks at each individual blob as a separate entity? Or do you want whole image, which a whole image says, I'm taking the extremes of all the blobs included and consider that one big blob? Okay, so you have that choice. Now let's think about what makes something a blob and what makes it a background. So what makes it an object versus a background? To be an object pixel, you have to be connected vertically, horizontally, or diagonally. To be a background pixel, it's only vertically or horizontally. That's it. Diagonal doesn't work. So if I asked how many black blobs on this image, what would you say? 1. If I said how many white blobs on this image? Trick question. 1. Yes. Because we're still diagonal. Because remember, to be an object. Now if I said how many white backgrounds, there are 5 white background areas. But if I said how many white blobs, all the whites are touching each other diagonally somehow. So it's still only 1 white blob. You can also add morphological filters. So you can close, open, dilate, erode, whatever your heart desires. But keep in mind, order matters. An open and a road will be different than an open on a road and an open. Even though I've used 2 opens and 1 erode, the how they go in is going to change the image to then be the next one. So it does throw it off, so be careful. You can also choose some pruning and filling, and this has to do with the area of your blob. If your initial image, let's say it's this hexagonal nut, and I've got a couple of holes in there, the initial image has one blob with 9 holes, and my blob area is going to be 900. Now, if I said I want to prune the image, what it's going to do is it's going to ignore the holes, but it doesn't add the holes to the area. So in this case, I have one blob enclosing one hole, and I pruned out these other 8 smaller holes. But notice I still have a blob area of 900. All I've done is I haven't included them as holes. I've just kind of cleaned it up a little bit. Or I could fill. And if I fill, what happens is I still have one blob enclosing one hole, but now all the different holes, their areas now goes into the blob area. So you can choose, do you want the holes to be part of the area of the blob or not part of it? Your choice. You can also choose which region. Like any of the other tools, where are you looking for your blob? So you can set what the region should look like. You also have the measurements. Okay, the measurements are what are you looking for with this blob? Are you looking for area, center of mass X, center of mass Y, or the connectivity label? Connectivity label is just whether it is blob or background, or I should say blob or hole. That's what it's letting you know. This is just the basic it comes out with. You can click that little, looks like a square with a little ta-da sign on it. It shows you all the different selections you can have. And there's a huge list of all the different things that you could be looking for there. You can go in there and you can say, okay, I want to filter things. Now at runtime just means I'm going to compute it every time this tool runs. Grid means I will only compute it if this particular form is open, where I actually see in the grid, then I'll see that. Otherwise, it doesn't compute it. And then filter means I'm only looking for a certain amount of that. So I can go in for my filter, and I can set it up so that, hey, exclude any blobs between this range, or include blobs only within this range. So I have the choice of how I want to filter it. You also can sort it. All your sort selections will be whatever of those different selections you have up there, which, like I said, by default is area, center of mass X, center of mass Y, and connectivity label. But if you add others, they will be available there as well. So you can do both ascending and descending order. You have your graphics set up. What do you want to see for your graphics? And then finally, you get your results. So first is N. That's just the index of the blob. That's how it falls into your list of whatever your sorting criteria was. Then ID is just a unique number. I'm going to show you a little topology in just a moment showing you ID number. Measurements, any of those measurements that you had selected, it will calculate it, and it will give you the results for those calculations. Now there are a whole different type properties you have. Now your geometric properties are going to include area, perimeter, center of mass, second moments of inertia about principal axes, because everyone needs that, right? Geometric extents and your principal bounding box. This is going to be the same no matter how your blob is rotated, because this is not being tied to the pixel grid. This is being tied to the blob itself. I mean, in effect it's the pixel grid, but it doesn't have to be rotated to be straight with the pixel grid. But they also have some non-geometric properties, and those do correspond to the pixel grid itself, such as what's your blob median, the second moment of inertia about the coordinate axis, coordinate extents, and your arbitrary bounding box. So that's going to try to make it squared up with the pixel grid so that you have a rectangular shape there. Now your topology, this is that ID numbers. When it takes a look at it, it tries to decide what is blob, what is background. So in this case, it says, oh, okay, this is one of my blobs. So I'm going to label this ID1, and this is going to be a blob. Now the blob has 2 holes. Has this hole and this hole. But this hole also has another blob in it. So it's setting all that up behind the scenes so it knows how things are setting up, and it's just giving it numbers, these ID numbers, so it has something to play with. So it says, all right, I've got all these different ones. Now let me order them according to what you want.
Doesn't this start with 0 again?
Not for the ID number. The N, yes, but not the ID number. So blob plays an important role in machine vision. Keep in mind, it's great for those times that you can't train it. You have no idea what something's going to look like. Or that you're trying to get size. Pat Max never told you size. Okay, so this you can actually get some size from. And it's also great in key situations where the model is difficult to train, or you want to take a look at something like, is it acircular? You know, is it touching my region of interest and I don't want to include it? Okay, so stuff like that. So let's try this out. What we are going to do is we are going to find these LEDs right here. Okay, that's what we want to find. Now we have to be careful with our blob. Okay, so when I take a look at it, I want to make sure that none of my dots are touching each other. If they're touching each other, I'm going to have a problem. Like, let's say I blur this a little bit. Oh, that's not blurring it. There we go. That could all become one blob. Notice how they're kind of touching each other. They could pick that up and think that that's just one big blob. So I definitely, with blob, I want to make sure that I'm keeping my focus on there. Okay, let's come out of this. So what I want to do is I want to drop in my blob tool. So cog blob, come in, drop that in. Now where am I going to pull my image from? Yep. Why do I want to pull it from the fixture tool? Because I want it to move with my part. Otherwise it's just going to be one place there and it's not going to move with it. Okay? So I want to move with it and I want to stay with my LEDs right here. So let me go ahead and run it once and see what's going on. So if I open up the tool and I actually look at what my blob image is, it shows me my blob image. Now everything that is white is my blob. Everything that is black are holes. Okay? So what I want to look for is I want to look for these. So the first thing that I want to do is let me reduce my area. So my region, I'm going to go ahead and say I'm looking for a cog rectangle affine. Go back to my current input image and I'm going to set it to be right around, come on. Now I'm actually going to make this a little bit high right now. I'm going to do this for a reason, okay? Just to make it a little bit tougher. So I'm going to go ahead and say run this just to see what's going on. So when I say run this, notice it's showing me my blob image here. Once again, anything that is white is my blob. Anything that is black is my holes. Anything here that is gray is not being considered. So as you can see right here, my dots are coming up as holes, and that's probably not what I want. So let me go back to settings, and you're absolutely right. My polarity right now, I'm looking for dark blobs on a light background. But is that what I'm seeing? I mean, here's my image. I'm looking for light blobs on a dark background. So let me go ahead and change this, run this, and see what my image looks like. So now, sure enough, here we go. I'm seeing only in white. These are my blobs. If I look at results, you'll notice I have 5 blobs. This is my first, then it goes to my second, third, fourth, fifth. Okay? Now notice my first is pretty close. I mean, my number 2 blob is pretty close to my number 3 blob. In fact, if I go back to my region, and let me just pull this over just a touch, run it again. Actually, I think I've moved it over too much. Yeah, I did move it over too much. Let me just go back to here. That's pretty good. Yeah. That's what I want. I'm purposely trying to choose this because notice how it's coming pretty close to what my circles are. Okay? There might be a situation that you suck in enough of this that it's coming pretty close to what my blobs are. Now, I can't get rid of this one pretty easy. And the way that I can do that is if I go to my measurements, I can actually filter my area. So if I take a look at it, that one's 586 square pixels. While the other ones are right around, 150, 162. Now, I don't want it too tight because some lighting's going to change it a little bit. So what I can do is I can go into my measurements. Instead of it being runtime, I'm going to say filter. And I want it to only include anything that might be between 140 and maybe 170. Let's say 175. Okay, go ahead and run that. So now notice I just got rid of that that big one right here. If I go to look at my unfiltered, it's there, but it's not coming in with my blob image. Now I have this one I want to get rid of. Now if I take a look at my results, because when I click on this, this turns blue out here, it's still less than the other, but it's not enough that I feel comfortable with. So I might have to choose something else, something that's going to tell me what makes this different than that one. That what? The shape, right. So if I go to my measurements and I say add new, here's all these different things I can choose from. Now there's a couple of things I could choose here. One that I could choose is, where's my, I think it's not clipped. For those of you who use Insight, not clipped is boundary blob. Okay? So if it's not clipped, it means it's not touching the boundary. So I could use that one and say, hey, if you're touching the boundary, you're out of here. But that might not be the greatest either. What I could do is let's try acircularity. So if I say acircularity, and let me just run it, what we can see inside the results is it's saying that this blob is almost 1. This one's pretty close to 1. This one's just a little bit over 1, while this one goes to 1.5. So it's a bit more acircular. And acircularity is just looking for how symmetric you are about a single point, how circular you are. If you're 1, you're quite circular. Okay? So what I can do is now, since I added acircularity, it's part of my list that I can filter things out. So once again, I could say filter, and I'm going to include only things that might be between like maybe 0.94, maybe 9.95 to maybe 1.05. Okay? So if I have that and I run it, now notice I only have those 3 blobs. Ooh, And then I can sort them according to area. I could sort them according to center of mass. In this case, if I wanted to order them right down the list, which one would I choose? Would it be, which one of these would I choose? Center of mass Y, exactly, because Y is going vertical. So it would put the one at this point, if I don't have ascending, it's descending. It'll do this one first, so let me run it. Does that one first, then the middle, then the top. I could just go in there and just say ascending, run that again, and now indeed it goes from top to bottom. Ooh, how exciting. So now let's go ahead and let's try to run this. And sure enough, it's finding them. If I take this, turn this over, then sure enough, it's only finding my 2 there. Having a little issue here. So when you're having a little issue like, let me see if I can get this to fail again. Okay, like this one, you might say, well, why am I failing? Those blobs should be there, okay? Well, take a look at what your unfiltered looks like. So the 2 blobs are there, they're just not getting picked up. So you might say, well, what's going on with this? Let me just go off for a moment. If I say unfiltered results, it's showing me the ones that were unfiltered, and it's showing me where I lost it. So because I moved my image, I don't have a completely orthogonal camera, notice that these went down to 0.91. So, oops, it went down below the 0.95. I might need to lower that a bit more to be able to take that into consideration. Cool, neat? Excellent. Groovy, man. And now, indeed, I do find it. Probably a lot more reliably now. So I'll let you guys put that in, play around with it a bit. Oh, it's already there.